But to go ahead and start us out, let's remind ourselves what a community is. What is a community?
It's like a bunch of populations
in one
chilling.
area.
Do what?
A bunch of different species in one area.
So, it's when you have many populations of various species in a given area. Members of a community are responsible for they're responsible for creating trophic levels, interspecific interactions, the first thing that we'll spend some time looking at this morning is looking at some of the interspecific interactions. So we'll talk about each of these. Let's first off, we'll start by talking about interspecific competition. This would be an interaction that is a negative and negative. And that's because in interspecific competition you have a competition for a limited resource. It has the possibility, when you see or when you look at interspecific competition, there's a possibility of competitive exclusion. In the case of competitive exclusion, you have a complete elimination of one of the competing species. And the competitive exclusion principle states that it is impossible for two competing species to coexist in the same place, which means the competition has to result in a removal, a loss of one of those members, one of those species would have to be going away.
Harry Potter. Neither one can live while the other two dies.
What?
Do you watch Harry Potter?
No.
Okay. Or have you, never mind.
I hang out in reality.
What?
It's all good. Question. Two competing species. It's really hard to find an example because anytime that you would hope to find an example, like this has already occurred. So I mean, if you stick in, two species that are going to be fighting for, let's say, you know, a rabbit, or that is their main prey, is the rabbit. One of those two is going to go away because there's going to be competition. Now, it doesn't have to be a direct competition. Does that make sense? This could just be the simple fact that one species gets to the rabbit faster than the other. So, first off, I think we want to get out of our heads that this has to be like where like a lion and a tiger are fighting. This does not have to be it. Competition can be where they're both going for the same resource. It's just one gets there quicker than the other. But to identify like a time frame or like an example, this is very difficult because this always results in one of the species having to go away. Now, that's not necessarily saying it's an extinction thing. That's just saying that it has to go away it has to go away to a different area perhaps, or maybe they are all killed off. But it is very hard to find an example of this, because once it's already occurred, both of them are gone. It's through this section of your book that the book introduces you to a pretty unique term, and this is a term that I really want to spend a little bit of time with. That term is ecological niche. Is anyone familiar with this term?
Which is like the role of.
Okay, it is very good. It's a species use of biotic as well as abiotic resources. It is the ecological role of a species. It's what it does. It's where it fits in. What the species does to increase its survival. Now, the reality is that once you kind of factor in competition with what a niche is, we can see a lot of times that it is very possible, and even maybe more of a likelihood, it is likely that a species will change, or will at least experience a change, in its ecological niche. Of course, it would make sense that prey will try to avoid predators. They'll try to do just about anything to avoid their death. In a lot of cases, this avoidance is going to be some type of morphological change. So morphological adaptation. Something they could be doing to maybe protect them from the inevitable, which I guess would be to be eaten. Of course, they can always, like, to avoid, they can always try to move away very quickly, but we'll focus on some of the morphological adaptations that we may find or may experience with these guys. So let's look at some of these morphological adaptations real quick. We'll first start off by talking about what cryptic coloration is. Cryptic coloration basically refers to a camouflage. Which makes a prey difficult to spot. Some prey have aposematic coloration. Which is a color and chemical defense system. They start to turn a certain color whenever they're about to release a chemical that's going to probably deter the predator. There's a style of mimicry called Batesian mimicry. And what Batesian mimicry does is it basically, you have a harmless species, but it looks like a harmful one. So a harmless species that would normally be eaten looks like a harmful one. Of course, it would make sense that the prey would not be eaten in the event that it looks like a harmful one, because the predator would probably avoid the bad species. So that would include avoiding the good species because it looks like a bad one. There's also Mullerian mimicry. Which is when you have two species that look like each other, and they're both typically bad species. Think of like a yellow jacket and a bee. They both have about the same outcome, the same effect. They look about the same. These right here are really good to know. And as you can tell, there's like just a little bit of memorization you have to do to make sure you get them straight in your head. For sure these will show up on the AP test though. Good? Realize your responsibilities with this? Okay. We talked about predator-prey. Let's look at herbivory right now, which if you think about it is much like a predator-prey interaction. In fact, I don't think there's anything stopping from calling it predator-prey interaction. It's a case in which you have a herbivore, which is a plant eater. So a herbivore that's eating plants. Which means that it would make sense that plants would develop and have developed. And develop chemicals to cause predators to avoid them. Now, if you think about it, we had talked about competition, we talked about predation, and we had talked about herbivory. This interaction, is it a very close interaction? In other words, if you're a herbivore eating a plant, which you very possibly are a herbivore in some cases, do you have to live on the plant to eat it? No. Or a predator prey, do you have to live on the prey? No. So your interaction could be quite far away, correct? That means that it's not a symbiotic or a symbiosis interaction. The term symbiosis means that you have to have, and this is not to be weird, the book states intimate contact, which doesn't mean like intimate in that regard. It means like a very close relationship. So symbiosis means that the relationship has to be close. Your book again uses the term intimate contact, which just means extremely close. And there are different type of symbiosis, that intimate contact style of interactions. For one's going to benefit, it's really kind of only appropriate to the other benefits. So most of the time when we think of what we suspect might be a commensalistic relationship, it actually turns out to be mutualistic, because if one's there for a positive, then probably the other one's there for a positive as well. Or it could be parasitic. So typically they're either one or the other. They could be very possibly commensalistic. A lot of teachers will teach predator-prey at the same time frame as these four, but it's truly not appropriate. Neither is competition, because for both of those you don't have to have the close, intimate relationship. They're taught in the same chapter because they're something you would see in communities, but you wouldn't necessarily talk about them at the same time. Cool? We okay with this so far? Okay. Let's move on and let's talk about species that exert tons of control. Let's talk about dominant and keystone species real quick. The term dominant species always refers to the species that is in the largest abundance. We measure this by studying the species biomass. What biomass is it's basically the sum total of all mass of all individuals of that species. So it is the sum total of all masses of all individuals of a certain species. So like, for instance, on my dad's property, I would say biomass being the greatest, you probably would include probably the grasses or the trees. And that would make sense because if you think about it, your dominant species typically has to be, most of the time, producer of some sorts. So some plant is probably going to be the dominant species. That's really just the way that trophic levels are derived, the way that feeding patterns exist. And typically your dominant species is always going to have an ability to exert tons of control. So it exerts tons of control. On lower species.
What do you mean?
For instance, if all the producers were to go away, what would happen to my dad's ranch? Yeah, I mean, basically it would be gone, right? Because you certainly couldn't feed cattle or deer or whatever else is on there, correct? So that's the tons of control. Like, you've never seen kind of thing shuts down the entire system. You know, like the butterfly wings flap in a forest, and then it's a typhoon in China or whatever. Butterfly effect, basically. It's kind of the same principle if you think about it. If one of these guys is gone, even though it's only doing like one interaction, that one interaction is pivotal, like, to a variety of other things. Cool? Okay.